So now let's continue with the topic 2.1, that is hydrostatic or fluid pressure. So this is the subchapter. So now we are at subchapter 2.1.10, that is pressure diagram. So this is the learning outcome. And then what is the pressure diagram? It is the resultant force and center of pressure can be found graphically for walls and other surface of constant vertical height, which is convenient to calculate the horizontal force exerted per unit width. So for the general principle, hydrostatic force per unit width, that is Newton over meter of immersed surface, is given by the area of pressure diagram. So the resultant force is given by the volume of pressure prism, and the center of pressure is given by the location of centroid pressure diagram. So consider the ABC. Okay, so we have A, B, C here. The pressure diagram of a vertical wall of a tank containing a liquid. So area of pressure diagram is half of the AB times BC. Okay, so because it is the rectangular, so we will divide by 2. AB times BC divided by 2 equal to H, okay, height, okay, times with the rho GH. Okay, so height is half of half of the H times rho GH, so resultant force will become rho GH square over 2 for unit width. Okay, for the force, resultant force will act through the centroid, which is at the depth of 2/3 of the H from A point. So from A point, the resultant force may act at 2 over 3 H. So yang tinggal is 1 over 3 to the bottom. So it act from the top is from 2. It act from the top A is at 2 over 3 H. Okay, so the location of the center, the location of the centroid P is at the 2 over 3 H from the top A. Alright, so now if the plane surface is inclined and submerged below the surface, the pressure diagram is drawn perpendicular to the immersed surface and will be straight line extending from P equal to 0. Okay, P equal to 0 at the free surface to P equal to rho GH at the depth H. Right, so H from the surface to the bottom of the immersed object, so it is H height. Alright, as the immersed surface does not extend to the free surface, the resultant force R, so is represented by the shaded area, okay, instead of the whole triangle. So it will just represent by the this what we call trapezoidal area. Alright, instead of the triangle area, and act through the centroid P of this area. So let's look into this example. A 2 meter times 3 meter tank with vertical side contain oil of density 900 kg per meter cube to a depth of 0.8 meter, which float on 1.2 meter depth of water. Therefore, calculate the resultant hydrostatic force and its location on the 3 meter side of the tank. So we have this tank with a 2 meter depth that immersed in the 0.8 meter depth of oil. So here 0.8 meter depth of oil and 1.2 meter depth of water. Okay, 1.2 meter depth of water. So we have 3 forces that is acting on the triangle F1, and then we have force 2 acting on the rectangle F2, and also F3 that acting on the triangle F3. So why we have 1, 3 because it is from immersed in a different types of liquid. Okay, so since we have different forces, so therefore we also may have 3 different height of pressure. So let's calculate the resultant force equal to the volume of the prism. So for the F1, we have volume of triangular prism. So F1 half, okay, 1.2, 1 over 2, okay, 0.5, that is 0.5 times with the 900. Why 900? Because the density of oil. Alright, oil times with the gravity 9.81 times with the depth 0.8. Okay, and then we have times with the h, that is 0.8, and also depth. Okay, depth times the width. Width is 3 meter, right? So it is given the 3 meter width, okay, side of the tank. Okay, so 3 meter, so you get 8.476 kilonewton. So now calculate for the rectangular prism. Again, rectangular because of the oil, so we use 900 times gravity, and then we times with the depth. Okay, so times with the B times D. So B is, sorry, the depth is 1.2, and then the depth is 1.2, and then the width is 3. Okay, so we have 25.428 kilonewton. And then for the F3, we have here for triangle, so 1 over 2, that is 0.5 times 1000 because it is density of water, times with the gravity, and then times with the h, 1.2, so we get D, that 1.2 times with the depth, with 3, so we get 21.19 kilonewton. So now to calculate the total, so you just plus all these 3 forces, so you get 55.094 kilonewton. And then you need to calculate the center of pressure. So by using formula 2, so for the HP1, okay, HP1 is here, HP1, okay, so we have 2, okay, so 2 is times with plus with 1/3 times with the 0.8, the depth, so it will give 2.267. Okay, same goes to the rectangle, so half of the depth, okay, 0.5 times 1.2, 0.5 times 1.2, okay, so the center, okay, so we get 0.6, and then for the HP3, sorry, this is HP3, 1/3, okay, so 1/3 from the top, okay, to this point, HP3, so 1/3, 1/3 is from the bottom to this HP3, 1/3, okay, times with the 1.2, so you get 0.4 meter. So you just total up you need to calculate the total of center pressure. So we have the F times with the F1 times HP1, F2 times HP2, plus F3 times HP3, right? So you get over force, total force, so you get 0.780 meter. So that is the answer for the resultant hydrostatic force. Okay, and then you can try this example. Okay, so we will continue in the next video. Thank you very much.